Alright, in this video we're going to take a look at the polar form of conic sections. And we're going to take a look at the graphs of conic sections written in polar form. And as we saw in the polar coordinates and equations notes and videos, that sometimes it's a little bit easier to write the equation in polar form than in rectangular or x and y form. So given a fixed line L and a point F that's not on that line L, and a positive number E, a conic section is a set of all points, P, that set of all points, such that the distance from the points to that other point F divided by the distance from those points to L is going to equal that value of E. Now the line L is called the directrix of the conic section, the point F is called the focus, and the constant E, that's not the base of the natural logarithm, it's the eccentricity of the conic section. So we saw in, for instance, the ellipse section that the eccentricity was C divided by A. More generalized definition of eccentricity of ellipse given to us right here. So this section is going to tie together a lot of the concepts that we've talked about in previous videos regarding the pieces and parts of conic sections. So the conic section is going to have eccentricity E, a focus F, which we can put at the origin for this purpose here, and the directrix line x equals negative d. So what that previous slide says is the distance from P to F, which in this case the distance from P to F is labeled as r for the radius, divided by the distance from P to L. So the distance from P to L is going to be this value of d plus r cosine theta is always going to equal E. So distance from P to F is r, the distance from P to L is d plus r cosine theta, and that's going to equal E. So looking at this equation over here, we have r over d plus r cosine theta equals E. And just like with polar coordinates and equations, we want to get r by itself to write it in polar form. So multiply both sides by d plus r cosine theta, we get r equals E times d and E times r cosine theta. And we can subtract ER cosine theta from both sides to get r minus ER cosine theta equals E times d. And now both these terms on the left have an r, which we can then factor out. So we have r times 1 minus E cosine theta equals E times d, and then divide both sides by 1 minus E cosine theta, and we get the polar form is r equals E times d over 1 minus E cosine theta. And so example 1, we're going to examine the effects that the value of d has on our graph. So we're going to fix E to equal 1 and then use the sliders of Desmos to adjust the values of d and see how that impacts our graph. So for instance, in example 1a, we have r equals ed over 1 plus E cosine theta. Well, if E equals 1, that's going to give us 1 times d, which is d, over 1 plus 1 cosine theta is 1 plus cosine theta. So graphing that, we have 1 for this numerator over 1 plus cosine theta. Notice it gives us a parabola. And as we adjust the value of d for positive values of d, notice it's opening to the left and it's moving our vertex back. For negative values of d, it's going to open it to the right, and the more negative it gets, the further back d gets on the negative scale, the further to the left it pushes our graph. So here we have, when d is negative 4, we have a vertex at negative 2, 0, and notice our y-intercepts are at 0, 4, and 0, negative 4. For something like d equals 3, we have an x-intercept, we have a vertex here at the x-axis. The vertex is at 1.5, 0, and notice our y-intercepts are at 0, 3, and 0, negative 3. So the parabola is going to open left or right, depending on whether or not d is positive or negative. The vertex is at 1/2 d, 0 on the x-axis. If d is positive, it's going to open left, and if d is negative, it is going to open to the right. So here we have d is positive, so it is opening to the left. and then the y-intercepts are at 0, and then plus or minus d. All right, part B. This time we're going to have 1 minus cosine theta in the denominator, so hide that. And 1 minus cosine theta, here's when d equals 1, so notice it's a parabola again, it's opening left and right, and changing the minus sign really changes the way it's going to open up here. And as we adjust the values of d, notice the more positive d is, it's pushing the graph to the left, and if d is negative, it's going to open it up now to the parabola is opening up to the left, and it's pushing the graph further to the right. So this time our vertex, when d is negative 4, our vertex is at 2, 0. Notice the y-intercepts at 0, 4, and 0, negative 4. When d is positive, like positive 3, our vertex is at negative 1.5, comma 0, and the y-intercepts at 0, 3, and 0, negative 3. So it's going to open left or right, vertex at negative 1/2 times d, comma 0. If d is positive, it opens right. If d is negative, it opens left. And our y-intercepts again at 0, plus or minus d. Example C, we're going to have d over 1 plus sine of theta. So cosine, open left or right. And hopefully you're got a guess as to what sine's going to do. And sine is going to open. And for this one, we have d is positive 1. It's opening downward. Our vertex here is at 0, 1/2. As we adjust the value of d, making it more positive, still opening downward. Here our vertex is at 0, 2 when d equals 4. And if we make d negative, notice now it opens upward. So here is when d equals negative 2. We have, excuse me, it's opening upward, and our vertex is at 0, negative 1. Notice our x-intercepts are at negative 2, 0, and positive 2, 0. And same thing with d equals positive 3. Our x-intercepts are at negative 3, 0, and positive 3, 0. So it's a parabola, it's going to open up or down, and that's related to the sine of theta here, just like cosine was related to left and right. Vertex is at 0, 1/2 times the value of d, so for when d is positive 3, we have the vertex at 0, 1.5, or 3/2. D is positive, it opens down. If d is negative, it opens up, and our x-intercepts are at plus or minus d, comma 0. All right, finally, example 1D, we're going to have r equals d over 1 minus sine of theta. So again, very similar to the last example. Pardon me. This time it's d is positive, it's opening up. If d is negative, it's opening down. When d is negative 2, our vertex is at 0, 1. When notice our x-intercepts at plus or minus 2. When d is positive 3, there we go. Our vertex is at 0, negative 1.5, and our x-intercepts are at plus or minus 3 and 0. So it's a parabola opening up or down. Vertex at 0, negative 1/2 times d. If d is positive, it opens up. If d is negative, it opens down. And our x-intercepts, again, are at plus or minus d, comma 0. All right, that about does it for this video. I'll